right, so real quick, the thing from 7.2 was this guy here. This is the main guy. Bless you. We talked a little bit about, I really hate the fact that the book does this. It's totally unnecessary. It makes the formula look a lot more disgusting than it needs to. They put right here, they put this. Right? They put Z sub alpha over 2. And we talked a little bit about why that is last time. And don't worry, I'm eventually going to get to your question. If I wanted to get like a 97% confidence interval, how could I find those Z-scores? What would I do? What area? What area would I need to look up? What's the only area the chart understands? Yeah, so like this area here. How would you figure out what that area right there is? What area is outside? 3%, 0.03, right? And then when you have to divide that in half, right? Cut that in half to get just the one side. So alpha is the area in the tail, or tails, cut in half because I just want one tail. That's why that symbol is there. It doesn't mean Z times alpha divided by 2. This is one symbol. So if I looked up here, that cut in half would be 0.015. I could find my Z-score and I could throw it into my equation. Right? Cool. So that's what that is right there. Just like back in the day, remember this thing back in the day? Does that look familiar to anybody? Oh, yeah. What that 2 mean? Does that mean you have to multiply by 2 or divide by 2? Or what's that 2 mean? The second Y. This is one symbol, right? One symbol the same way. It's one big old freaking Z symbol. Just mean the Z-score that relates to the confidence you want. So coming back to the actual question, it was number 10, right? Yes? Okay. Number 10. So they've got their interval. They're however confident that the real percentage, without the hat on there, right? With the hat means it comes from the population. With the hat is sample, without the hat, population. Cool. Right? So they think that the real proportion, the real percentage from the population is somewhere between those two. Looking at the fact that the formula to make that confidence interval, what would sit right in the middle of the interval? What would be right in the middle? So this would be 0.72 to 0.78. That's some distance away from the middle, but what's right in the middle? What do I keep adding, subtracting from? P hat. Now in 7.3 it would be the mean, right? X bar plus or minus Z, blah, blah, blah. That's 7.3. I get a percentage from my sample, and I say that can't be right. If I find the percentage of you guys that smoke, and I say, okay, I want to say something about all of Grossmont College, I'd have to say give or take something to cover my ass because you guys are a small sample, right? And probably the sample, the whole population probably didn't have the same proportion as you guys would. That's the whole idea here, really. I get something from a sample. It's probably not true. Give or take something to say that I'm so sure that the real population is somewhere in there. So what's right in the middle of that? It's going to have to be p hat. P hat must be right in the middle of any confidence interval that you make for a percentage. Period. Why? Because what do you do with p hat? You add something to it and you subtract something from it to get those numbers, right? Give or take. Add, subtract. Up and down the same amount. So what is right in the middle of 0.72 and 0.78? 0.75. So what's p hat? 0.75. And what did you add to p hat and subtract from p hat to get up to 0.78 and to get down to 0.72? How far away is 0.75 from 0.78? 0.3 or 0.03, yeah. That would be your error. Right? So the book actually puts it like this. And then they have the E separate. I kind of write it all together. But this is actually kind of better for this problem because my p hat's got to be right in the middle of my interval. Of course it does. Because how did I make the interval? by adding and subtracting the same amount from p hat. So what must be right in the middle? P freaking hat, right? That's how I made the interval. So the middle is the p hat. You can always just take the average of these two, right, if you wanted to, if they were uglier. That was pretty easy to see was 0.75. How much is the error then? Well, how much am I off by? Give or take 0.3. Because I went up 0.3 and went down 0.3. So what's the error? 0.03. So I can say 0.75, give or take 0.03. And now I give you the 0.72 and the 0.78. Right? So they must have seen 3/4 in their sample did something. And because their sample size and so forth, whatever they had to do to calculate this piece, they said they were off by about 3% at most. Give or take 3%. That's the way to look at this. 75%, give or take 3%. Because I might be off, just to cover my ass. Right? Okay, but now we see that the number is not just coming. They don't go, what sounds good? Let's say 10%, give or take 10%. No, you calculate the damn thing. The bigger your sample, the smaller your interval could be. Because from day one, we knew that the bigger your sample, the more you trusted it, right? The less I have to say I'm off by. And it makes sense mathematically. If n gets bigger, what happens? This whole thing gets smaller. I'm dividing by a bigger number. So it kind of goes along with all of our concepts we've had since day one. Okay. It's a long-ass answer for a very short problem, right? You just take the average of the two, right in the middle, and you see how far it is from one side. That's the error. That's how much you think you're off by. There's several problems that are actually the same problem. They just kind of word it a little bit differently. Like number 14, it's the same problem as number 10, really. Different numbers, but the same idea. So what would you do for number 14? What's right in the middle of those two? P hat, I like it, but what is it? 0.774. And what's your error? How much do you go up or down from here? 0.002. See, that wasn't hard, man. That's pretty damn easy. Okay. So I could actually give you that problem outside of the stats class and just say, can you tell me what the middle of this interval is and how far from the sides it is? That's really all they're asking. But now in stats, we know that the middle is p hat and how far it is the error. Yeah?
Can you do number 18?
No. Yes, I can. Let's see. 18 is the first place you got to actually calculate your own. The other ones they gave you in interval was already all done. You just had to kind of tease out what they found. 18 says, all right, enough of that crap. You do your own work. So 18 says, n means the same it always has meant. So I talked to like 500 people. What does x represent? From like NPQ problems for a binomial problem, what was x? So if I asked people if they're left-handed, and I found 220 out of 500, 220 would be the number of successes, the number of people that said yes. It's the number of whatever I'm looking for, right? So how do I calculate p hat from that? How do I calculate p hat from what I know? What does p hat represent? Say again? Percentage from the sample. All right, well, how many did I see in the sample that matched what I looked for? 220 out of 500. So that's how you get it. The percentage is always part divided by whole, right? So 220 people were successes out of 500 total. Now, part of me hates this kind of problem because there's no connection to real life. They don't tell me, am I looking at 500 dogs and seeing how many of the dogs have had their rabies shots, 220? That's kind of scary. Or am I talking about people? Am I talking about shoes? How many shoes are listed at the right width or some weird shit, right? They don't tell me anything. I kind of hate that. This is just purely nuts and bolts. P hat is always x over n. But it's actually easier in what some of you guys would call a word problem. If I said I talked to 500 people and 220 of them were left-handed, what percentage were left-handed? 220 out of 500. That's what p hat is, the percentage from what I saw, right? Here it's kind of divorced from reality a little bit, just pure numbers, but oh well. What is 220 divided by 500?
44%.
I love it. So what's q hat? Careful. 0.56, good. And what's the z-score going to be for a 99% confidence? Who remembers the quick way to find that?
Negative 2.5.
Well, 2575, right? The negative or the positive doesn't matter. It's built into the formula here, right? All I care about is that z is 2.575. Now, how do we get that number? Where'd that come from? The chart. There's like a little baby chart down there, or you can do it the old-fashioned way. If I want 99% confidence, how much is out here?
0.005.
Yeah, on one side would be 0.005, right? If you look that up into the chart, you have to look in the body. You look back out, you're going to get 2575. It'll be one of those little asterisk places that you follow. How are we doing so far here? So I really want you to see, nuts and bolts wise, this section should be easy. You're using the z-score chart to find something based on how confident you want to be. Right, most of them should actually be in the little baby chart, 99, 95, 90% confident. Those are really well used and known z-scores. You're calculating the p and q hat from what they tell you. This is all very nuts and bolts-ish. The idea, too, should be really simple. If I take a sample and find 44% are left-handed, I'm not going to say 44% of the whole population is left-handed. I'm going to say 44% give or take some, because I know I'm probably off. I know my sample can't possibly be truly exactly the same as my population, no matter how random I made it, right? That's the whole idea here. I see this, and I think the real thing is that give or take something. It's going to be something close to that. So here I get, what are they asking for here? I've talked too much. Just the error, right? I just got to plug and chug. And be real careful when you go to plug this into your calculator. Let me show you exactly how to do it. The fewer parentheses you use, the better, because it's hard to keep track of them. So this will be 2575 times the square root 0.44 times 0.56 divided by, where'd it go? 500, close parenthesis. So open parenthesis here, close parenthesis at the end. For those of you who have the new TI-84 that doesn't open parenthesis, the bar will just get longer. And you have to hit the over key to get out of the square root. For the rest of us, when I close that parenthesis, I come out of the square root. The biggest mistake I see is people do this. They put a parenthesis there and a parenthesis there. Well, that means that n is not in the square root. You come out of it too early. That sucks. Just don't close it till you're really done. Let's see if we all get the same thing here. Cool, man. Well, 572, we can round it to there. 3 places for p hat, q hat stuff. That's fine. So if you didn't get that, you might want to come see me after class. I want to make sure you're putting it in the calculator correctly. That sucks to have the problem set up correctly, but then you put it in the calculator totally wrong. Most p hat problems are going to have an error somewhere between 2% and maybe like 7% at the most. If you get an error of 20%, you're probably wrong. It's not impossible, but it's very unlikely. Okay. Any other questions from? Yeah. 22. Well, I'm just kind of slowly making my way down here. All right. Oh, let me make sure you guys understand. You don't do this to be